Hi, and welcome to another in our series of short demonstrations of new features that have been added to MachineWorks in the MachineWorks 8 releases. Just a reminder that MachineWorks is only available as a software library. If you're interested in a ready-to-use end-user product, then please contact one of our customers. MachineWorks snapshots are a fast and convenient way to store the current state of the in-process stock within a machining session. Once stored, snapshots can be easily and quickly restored. They can be thought of as bookmarks, allowing the user to jump to different places in the toolpath and inspect the actual in-process stock at each of those locations. However, snapshots offer more than just a bookmarking function. For example, a user could save a snapshot at the end of one machining cycle, or even partway through it, and then investigate the effects of different machining strategies going forward from that point. As MachineWorks is based on a solid model, it's also possible to perform Boolean operations between snapshots, for example to create a solid of the material that has been removed between two snapshots, or the material that was not removed by one machining strategy when compared with another. So, here's an initial stock in MWNC demo, the internal tool used by the MachineWorks development team. First, we machine a pocket and mark the cut stock faces in a green colour. And at the end, we save a snapshot. So you can see in the DOS window on the right, it says create a new snapshot 1, processor time, etc., etc. So we've saved a snapshot. And let's do the same for 3 other pockets. We've machined and a snapshot's been saved. We've machined and a snapshot's been saved, etc. So now we're going to restore the stock, the in-process stock, using the last saved snapshot. So there we have a complete in-process stock model, but that was stored before the last pocket was machined. And if I double click again, I can roll back progressively through the snapshots. Now I don't have to do that in order, I've just chosen to do so to show the concept. And later on in the demo we'll jump around much more freely. So now we've jumped to the snapshot we stored after the first pocket was machined. And we can now subtract that snapshot from the original stock model to get a solid model of the volume of material that was removed by that pocket machining operation. So there we have it. There's a closed BREP solid of the material removed. And just to reinforce that, you can see here I've taken some slices through that model and taken some slices in the other axes, and you can take as many slices as you want, so you can get curves of the remaining volume of material. So oops, let's try and get that orientated again. So now we'll do the same for all the pockets. So here we've subtracted in effect the final snapshot from the original snapshot to get all the pockets. And similarly, if we do the snapshot after the first pocket with the snapshot after the third pocket, then we get a solid of these 2 pockets. Okay, so now let's try the same thing but with a more complex simultaneous 5-axis toolpath for an impeller. So in this case, I'm just going to do a sequence of machining, and as you can see on the right, we're creating the snapshots as we go along, and you can see that it doesn't really affect the speed of the machining or the update. So we've now created 4 snapshots looking at that, and we've done some machining with different tools, etc. So first of all, I'll roll back to the first snapshot, and then you can see we have this, still have a solid model. Double click again and I've rolled back to snapshot 3, snapshot 2, snapshot 4, and then back to the initial the snapshot that was taken at the point of the initial stop. So now I've created a difference between snapshot 1 and 2. So it's a Boolean subtraction between the solids of the in-process stock when snapshot 2 was taken and when snapshot 1 was taken. So this is a boundary representation which can be queried, sliced and analysed in the same way as any other of the solids in a machining session. And just to show that, I've created 50 slices here in XY, and we can see those, and I'll create the same in the other two axes. And so there, you know, we have a nice set of curves that you can work with, smooth, etc. So going back here, I've now taken a difference between, so I've subtracted snapshot 3 from snapshot 2 in this case. And in this case, I've taken a subtraction of snapshot 4 from snapshot 3. So if we, okay, now we're doing some different machining. So apologies for the angle, but we've rolled back. We've rolled back to snapshot 0, and we've done a different toolpath with different tools, and we've taken snapshots along the way. And so now we'll just show you that how you can mix these things up. So we've taken 3 more snapshots in that second sequence. So I'm going to now restore all the 7 snapshots in the sequence that we stored them. So from the first toolpath first, and then the final 3 from the second toolpath. So there's number 1, or number 0, number 1, number 2, number 3, number 4. And now we're switching to the second toolpath, 6, 5, 6, and 7. And we can even do differences between snapshots from different toolpaths. So in this case, we've done snapshot 7 from the second toolpath has been subtracted from snapshot 4 from the first toolpath. And here you can see the different tool colorings on the front and back of that snapshot. So if you want to analyze, as I said earlier, for example, differences in material removed by the 2 different machining strategies, then this is a great way to do that. And finally, one more. So in this case, we've taken snapshot 7 and 4 again. Yeah, but yes, in this case we've actually subtracted snapshot 4 from snapshot 7. So it's the opposite subtraction to what we just did before to give a different set of material in the result. Okay, so that's a very quick demonstration of snapshots. I think it's fair to say our customers have already found snapshots an interesting new feature, and they've put them to use in a number of ways that we never anticipated. It's worth noting also that snapshots are stored in a very efficient manner. So once the first snapshot's been taken, all the others are stored as an incremental difference to the previous ones. So the full stock representation is not stored in each snapshot. Application developers also have options to control which extra metadata, such as materials and cut numbers, are stored with a series of snapshots. There's also a helpful set of functions for managing attributes and properties of the snapshots, and also for working with trees of snapshots, which can become quite complex if a user decides to explore many what-if scenarios. Snapshots are also supported for material addition as well as removal, so they can be used for additive simulations where you're actually adding material on, and hybrid material where you're using the machine tool or a robot or something like that to add material to a part and then perhaps CNC machining it afterwards. If you'd like to know more, as always, please don't hesitate to get in touch via the forums on www.machineworks.com. Many thanks for your time and for listening.